In the introduction to trigonometry, let us talk about complementary angles. What are complementary angles? When the sum of two triangles, when the sum of two angles in a triangle are equal to 90 degree, they are called as complementary angles. In a triangle, there are three angles. The two angles, if their sum equals exactly 90 degree, they are known as complementary angles. The meaning of complementary angles. In the trigonometry, you are mainly concentrating on the right angle triangle. In this right angle triangle, one angle is already 90 degree. The other two angles are acute angles, angle A and angle B. And these sum of these two angles always equals to 90 degree in the right angle triangle. Therefore, in this right angle triangle, angle A and angle B are complementary angles. How are these complementary angles are related? The complementary angles is theta and this angle is 90 minus theta. Angle A is theta, angle B is 90 minus theta. Sum is equal to 90 degree. What is the relationship between these complementary angles in terms of trigonometric ratios? The relation between these complementary angles in terms of trigonometric ratios. Let us consider this triangle. In this triangle, let us specify the lengths of the triangle. Three lengths are there. In general, x, y, z length. This BC, let us call it as x length, and CA y and AB equals z. Specification in general, the lengths. And let us take this triangle, same triangle, x, y, z, the lengths of the three triangles, the lengths of the three lengths of the triangle, x, y, z. And among these two angles, let us consider this angle. First, let us consider this angle, this acute angle. For this angle, this length is called as opposite side. X equals opposite, y equals adjacent. This length is adjacent side and this length is called hypotenuse, this side. And for this triangle, with respect to this angle, let us write all the trigonometric ratios. Sin theta, as you know, opposite by hypotenuse. Cos theta is adjacent by hypotenuse. Let us write the value for sin theta x by z, cos theta y by z, and remaining trigonometric ratio cosecant theta, the inverse of this, z by x, and secant theta, inverse of this, z by y, and tan theta, sin theta by cos theta, x by y, x by y, cot theta, inverse of this, y by x. So, in terms of x and y, you written all the sin theta, cos theta, all the trigonometric ratios. Let us call them as equations 1, 2, 3, up to 6 equations. So, you have 6 set of equations for this triangle. For the same triangle, let us take this angle. With respect to this angle, angle B, what are the trigonometric ratios? This angle is 90 minus theta. This angle is theta. If this is the angle, with respect to this angle, and these sides are specified, this becomes opposite side. This becomes adjacent side. This is hypotenuse. So y equals 0, x equals a, Z equals H. Z is hypotenuse, X is adjacent, Y is opposite side. Let us write the trigonometric ratios for this triangle. This theta is 90 minus theta. Let us write all the six trigonometric ratios. Sine of 90 minus cos of 90 minus theta, like this. Sine of 90 minus theta, the same definition. What is that? Opposite by hypotenuse. Y by z. Cos theta, adjacent by hypotenuse. And remaining cosine theta, inverse of this. Cos theta, inverse of this. Tan theta, sine by cos. Y by z. Cot theta, inverse of this. X by y. So we have six sets of equations, six set of equations for this triangle with respect to this angle, and six set of equations for this triangle with respect to angle theta. Now we can compare these equations. This is one set of equations, six are there. This is another set of equations or another angle. Look at that. In this, one equation is same. One of the equation is same as the other equation in this. Compare this. This equation 1 is same as equation 8. Look at this. Similar equation, same equations. X by z, right hand side, x by z. Right hand side, right hand sides are same. The left hand sides must be same. Like this, every equation, equation is similar to another equation in this set. On comparing these equations, equation 1 and 8, we get this. And equation 2 and 7, 2 and 7, we get this. Sin theta equals cos of 90 minus theta. From this equation, cos theta equals sin of 90 minus theta. And comparing equations 3 and 10, cosecant theta equals secant of 90 minus theta. On comparing equation 4 and 9, these are same equations. Secant theta is equal to cosecant theta, cosecant 90 minus theta. Cosecant 90 minus theta. And finally, comparing the equations 5 and 12, 5 and 12, we get tan theta equals cot of 90 minus theta. And equation 6 and 7, cot theta is equal to 9, tan of 90 minus. Look at the equations. It is sine, you can write sine theta, you can write it as cos of 90 minus theta, or cos theta as sine of 90 minus theta. In these, sine and cos are complementary angles. They are called as complementary angles. We can write sine theta as cos of 90 minus theta and vice versa. Similarly, these among these two, cosecant theta and secant theta are complementary angles. Cosecant theta and secant theta are complementary angles because cosecant theta is equal to secant of 90 minus theta, or secant theta is equal to cosecant of 90 minus theta. And one more set, tan theta and cot theta are complementary angles because either tan theta is equal to cot of 90 minus theta or cot theta equals tan of 90 minus theta. So we have three sets of complementary angles. Sine and cos are complementary, cosecant and secant are complementary, tan and cot are complementary angles. So this is how the complementary angles in a right angle triangle are related in terms of trigonometric ratios. Sine and cos are complementary, cosecant and secant are complementary, tan and cot are complementary. They are known as complementary angles.